This paper presents a test of a simple formula for calculating approximate intensity, duration, frequency curves. One of the objectives of Klima Digital is to try to estimate rainfall intensities that result in mudslides or rock slides. But the problem is that we have very little data. Normally, when we estimate intensity, duration, frequency curves, we need long time records of sub-daily data, and we don't have that here. So in the end, we ended up with a simple formula that can actually help us. And this is the formula, and basically it estimates the return level, XL, as an expression of the wet day mean frequency, which is mu here, and the wet day frequency here. And those two parameters can be estimated from daily rainfall records on any site. So these are site specific. And then it estimates it for each time dimension or time scale, L, and that's in hours. So it could be 1 hour, it could be 2 hours, it could be 6 hours or 24 hours for a day. And then it estimates it for a return period, tau here, and that could be a 2-year return period or 10-year return period or 100-year return period. And this expression has been inspired by the fact that the daily rainfall is close to being exponential. It's not quite. It deviates from being exponentially distributed. So then we have a correction factor alpha here to accommodate for the fact that it's not exponentially distributed. It's very close in the smaller amounts, but not in the higher amounts. If we plot the return level, the log of return level against log of timescale L, then we expect to see almost linear curves with a slope zeta. So when we do actually plot these like the return levels against the timescale, these are for 14 sites in Oslo. We see that the relationships are almost linear, and also we can get an estimate of the slopes. And then from that we can derive zeta, and this is in a way a downscaling with respect to time, but we also can use this formula to downscale IDF curves for the future.